Differential equations are equations with derivatives in them. In this course, you will only learn how to solve the simplest type of differential equations in which you can separate variables. You may be asked to find a general solution of the differential equation, which give you a family of curves, or a particular solution, which gives you a single curve. Our procedure for solving differential equations is to rewrite y prime as dy over dx, multiply both sides of the equation by dx, separate variables. This is the most crucial step. You gotta have y's on one side, x's on the other. Integrate both sides of the equation, solve for y if necessary, and use an initial condition to solve for c if an initial condition is given. Steps 5 and 6 are interchangeable. For example 1, find a general solution of x plus 2y prime equals 0. Let's replace y prime with dy over dx. I'm going to interchange steps 2 and 3. So first I'm going to separate the variables so that y's are on one side and x's are on the other side. And then I'm going to multiply both sides by dx. So now dy is with y and dx is with x. Now it's time to integrate both sides of the equation with respect to the variables on either side. Now we only put c on one side. Why do we only put it on one side? Well, we have a c value here, let's call that c sub 1, and a c value here, let's call that c sub 2. Then if I subtracted c sub 1 from c sub 2, I would get another constant. Let's call that c sub 3. So at the end of the day, you only need to put the constant on one side. It accounts for the constant from the integral on the left and the integral on the right. And now we're going to solve for y. Notice that the square root of a sum is not the sum of those two square roots, so our c does need to be under the square root. To write your solution as a pair of possible functions, we will separate that. One will be positive root negative x squared over 2 plus c, and one of those will be negative. Find an equation of a function which contains the point 0, negative 3 and whose slope is the following for each point on the curve. So they've just told us that the slope is this. That means dy over dx is x times e to the x squared over y. Begin by multiplying both sides by dx. We're going to get the y's on one side and the x's on the other. Multiply both sides by dx and by y. Integrate both sides. The integral of e to the u prime is e to the u. We have to make sure u prime is in there. So we have to multiply 1/2 and 2. Now I'm going to solve for y. Start off by multiplying both sides by 2. To multiply this by 2, we just get e to the x squared. To multiply c by 2, that's just c. 2 times a constant is still a constant. This right here is our general solution. To find our particular solution, going through 0, negative 3, we're going to need to solve for c. This makes our function y equals plus or minus square root e to the x squared plus 8. Or here it is written as two solutions. First, we're going to find a general solution for example 3, and then a particular solution. Begin by multiplying both sides by dx. We're going to get the y's on one side and the x's on the other. Because our variables do not match, but we have products, we're going to need to divide both sides by y minus 2 and divide both sides by x. After successfully separating the variables, let's integrate both sides. To solve for y, we'll exponentiate both sides of the equation with the base of e. This will isolate absolute value x, but since our result of e to the something can never be negative, we have to keep that absolute value there because there's no way you can plug in a negative, it wouldn't make sense. By properties of exponents, I can take the base e and multiply it by base e to the power of the other part of my sum. Why would I do that? To simplify e to the c. E to the c is simply c. It is a constant. C represents any constant. Absolute value x will equal now c times e to the ln absolute value y minus 2. E to the ln of something, those are inverse operations. So we can now write this as absolute value y minus 2. To solve this equation for y, we'll make x equal c times y minus 2 and negative x equals c times y minus 2. And now we can solve for y in each of these equations. To find our particular solution, we're going to plug in 1 and 1/2. It doesn't matter which one we plugged it into, we got the same particular solution for when x is 1 and y is 1/2.